All right, so in preparation for your quiz now on Tuesday, I did move it back to give you guys a little bit more time. I do want to just take some time. I've introduced all 5 chemical reactions plus the physical reaction dissociation. Okay. 2 days ago and yesterday. And what your quiz is going to ask you to do, which I keep on telling you incessantly, because I want you not to be surprised at all of the level of knowledge I'm going to ask you to know, is I will give you 2 word problem reactants. So I will say the name. Pure fluorine reacts with, for number 1, pure fluorine reacts with calcium bromide. And I can even write this out actually for you. So what I would do in the word problem is I would say pure fluorine reacts with calcium bromide. And I would expect you to be able to figure out the chemical symbols, the chemical formulas for those 2 reactants. And then I say predict the products and balance. So immediately, what should you notice that you have? Your 2 reactants are what? How would you describe each of these reactants? They're a what and a what? Min? They're metal what? They're not all metal. So there we have a gas here. We have a metal here, but we have a metal bonded to a non-metal. Okay, so what you should immediately notice here is, as far as identifying the type of reaction, okay, what you should notice is that we have a free element, a plain diatomic, plus an ionic compound, which means that what type of reaction are we working with? Single displacement with halogens. Excellent. I'm trying to give you guys hints of how you think through this problem. So this is a single replacement or single displacement with halogens, i.e. we're replacing the anion. We're replacing the negative because a halogen always takes on a minus charge when we do ionic compound making. So, and I see I did not leave enough room between the reactions. So let me quickly move things down and deal with this. Okay. Okay. So what we have here, single displacement, that means we would normally look at a chart and say, hey, is this actually going to happen? Because not every single displacement reaction happens. But if I'm going to give you a reaction, I'm going to have you follow through. So I'm going to give you a reaction that does happen. Okay. So what would this become then? What would my products be? Yes, Aislinn. Calcium fluoride. Predict calcium fluoride. And do I just do it like this? We're making a new ionic compound. So what do I have to check? I have to check charge. Excellent. Which means I'm going to have to check my subscripts, my small numbers. Okay. So I look at calcium. Calcium's a 2+, but fluorine's a 1-. So how many fluorines am I going to need? 2. Okay. And then I have free bromine. Do I just write free bromine? What's bromine? What? Bringelhoff, which is a diatomic. Excellent. So this is a diatomic, which means that I'm going to need 2 bromines. Now that I've made the compounds correctly, now I check last step on your quiz for balancing. Then I'm going to ask you to balance the darn sucker. Okay. Now that you've made compounds, you balance last. Last, you balance, which means last, you figure out the coefficients. So I look at this and I say, okay, I have 2 fluorines at the beginning, 2 fluorines at the end. Cool. I have 1 calcium, 1 calcium. Oh, that's kind of nice. And I have 2 bromine, 2 bromine. Ayo, this one was already balanced in a 1-to-1-to-1 ratio. What does this translate to? I have one molecule of fluorine gas reacts with or does a single displacement. Maybe I'll just name it. Does a single displacement reaction with one calcium bromide to produce one calcium fluoride and one bromine gas. And that is what that chemical reaction tells me. That's the translation of that chemical reaction. Okay. See how that really stacks all of your knowledge together? That's what I'm expecting to do on the quiz for 3 reactions. And then you're going to write a CER based on the products that you identify. Which unknown reaction is this? It's going to be like a who did it type of thing. I have this unknown reaction. It's between these 3. Based on your ability to do all of this, which of these 3 fits the reaction I saw mysteriously in lab? Claim, evidence, reasoning. It's a lot of stacking of knowledge, but you totally can do it. So next one. Okay. Here I have, okay, how would I write this out? Step 1, I would have told you I have magnesium oxide and and I probably would tell you, and it reacts to form its simplest compound. Reacts to form its simplest simpler elements. Maybe I should put that way, simpler elements. So automatically, if you see a lonely single compound and then an arrow, what type of reaction is this going to be? Decomposition. Excellent, you guys. This is totally a decomposition reaction. Okay, which means, by the way, I break up into my neutral simpler compounds. So what I have here is magnesium oxide. It's going to break up into pure magnesium. And I'm going to color code this to pink so you guys can see my steps. Pure magnesium, and magnesium is definitely a solid. Like I did the reaction for you. It was a solid strip. And do I just write O? No. What's unique about oxygen? Diatomic. So it's O2. And that is always a gas. What's the only diatomic that's not a gas usually? Bromine. Bromine tends to be a liquid when it's a diatomic. Okay. So now I balance it. So what I see here is for balancing, I'm going to have to say, okay, I have 1 magnesium and 2 oxygens on the product, but I have 1 magnesium and 1 oxygen on the reactant. So I'm going to put a 2 in front and a 2 in front, and I get my balanced reaction. What does this translate to? 2 magnesium oxides compounds decompose into 2 magnesium solid solid particles and 1 oxygen gas molecule. And that's what that translates to. Yes.
Why did you change
to balance it? Because I end with 2 oxygens, but I started with 1. So I need to get 2 oxygens in the beginning, but if I do that, because that reactant oxygen is attached to the magnesium, I need to also double the magnesium at the end. Yep. I mean, I did it in my head. We could have done the full write out. This one I thought was simple enough that we could do in the head. But you could have just done what we normally do, right? You could have done MG101, MG102, and you would have seen that we would have had to multiply by 2, multiply by 2. And of course, these are bonded together, so that's why you also multiplied this oxygen by 2. Does that make sense? Perfect. Okay, next one. All right, let me move this down. This one, what would I say to you for the quiz? I wouldn't say very much. I would say silver 1 nitrate reacts with magnesium oxide. And I would just leave it at that. And I would expect you to be able to get those compounds. Which means, by the way, you'd have to know your polyatomic nitrate charge. You'd have to know the formula. It's a lot of knowing. Chemists are called smarty pants for a reason, and they love to toot their own horn about it because they know a lot of material in their brain.
And there's only one silver because NO3 is
Yes. And I told you that the Roman numeral is the charge of that transition metal. Okay, not the subscript, not the amount, the charge. So then what I would say is, what would you automatically know this about these 2 reactant species? They're what? What? Double displacement. But how would you know? These are 2 ionic compounds, And if you have 2 ionic compounds, you have a double displacement reaction. So that's how I would know what type of reaction based on, okay, the reactants. So then I predict the products. I'm color coding everything, the process. Pink, predict, right? I would switch the cations. I like to think of it as switching cations. That's just my thing. You could think of it as switching anions. But a positive has to switch with another positive and be partnered with a new negative. You cannot partner 2 positives together and 2 negatives. That doesn't work. So what I'm going to do is I'm going to switch my cations. So I'm going to do Mg now goes with NO3. And, okay, Ag now goes with O. But here's the thing. Can I just leave it like that? What do I have to check for if I have 2 new ionic compounds? Excellent. I have to check for charge canceling, which means I got to figure out my new subscripts. Because I make 2 new ionic compounds, which means I make 2 new charge combinations. So now, okay, so what I'm going to see is that magnesium is a 2+ charge. Nitrate is a 1- charge. So how many nitrates do I need? 2. If I didn't write the parentheses, I would write N and 32 oxygens. That's wrong. Please write the parentheses. Because it's a group. I need 2 of those groups. Okay, Ag. Ag has a charge of, I told you in the name, 1. And oxygen always takes on a 2- charge. So what are my subscripts? What's my new formula? Ag2. Okay? Because I need 2 1-charge silvers to cancel out my 1 2- charge oxygen. Now that I've done that, now that I've made the good compounds, now I go through and I balance. So I see that I have Ag1, NO3, 1 of them. The polyatomics are preserved, so I'm going to treat it as 1 unit. Mg1, oxygen 1. And I end with Mg1, nitrate, 2 of them bonded with Mg. Ag, 2 of them bonded with 1 oxygen. And then I do my little chickadee trick track. Okay, so I notice my NO3s aren't equal. I'm gonna multiply by 2, gets me 2 and 2. And now I'm balanced. So then I just put in front, I put 2. And now I have my balanced chemical equation. You are hands down guaranteed to have a double displacement reaction as one of the problems on your quiz. So please study your polyatomics because hands down, you're also guaranteed to get an ionic compound that has a polyatomic and a transition metal with a multivalent charge. Okay. Okay, last one. So one thing I mentioned about double displacement reactions yesterday was that when we switch ionic compounds, usually one of two things can happen. We get one new compound that is a solid and one new compound that still breaks up no matter what. We call it dissociated. Doesn't actually create a new product, just as a physical process. But then sometimes we get the other case is that you do all of that work to have everybody break up anyway and not create a single new substance, because in reality, everybody breaks up into a dissociation reaction, a physical process. So that's what I introduced yesterday toward the end, is this kind of special subcategory within double displacements. Not every double displacement actually makes a new product. Lots of double displacements are just a really fancy physical split up and switcheroo with no new substance, no new lasting bond made. So the category of a non-lasting bond of an ionic compound is known as a dissociation reaction. What's the number one difference between decomposition and dissociation reactions, Liam? Water. Okay, water. When you see this in a watery environment and you have an ionic compound, okay, you gotta bet your bottom dollars that this is dissociation, which is totally not equal to decomposition. Okay, it is not equal to decomposition. So what would I have told you if I give you this on the quiz? I would say that silver 1 nitrate is dropped into water. And then I'd be like, predict the products. Predict the results of this very much physical process. This is a very much physical process. Okay. Well, so what then are my products always? If it's a physical process of the splitting of ions in ionic compound, what makes them unique? Your products are always what? If your ions are split, they're always carry a what? No, because we're splitting the ions, which means that they carry a charge. That's the second way you can identify if this is a dissociation reaction, not a decomposition. Decomposition breaks up into neutral particles. Dissociation is the literal thwacking of an ionic compound being like, burp, okay, and splitting up their ions, which means you're going to get charged particles just floating in water. So this becomes Ag positive, and we say aqueous because it's in a watery solution, and NO3 minus aqueous. And those are our products for this physical process of just thwacking apart an ionic compound. Not a chemical reaction. No new substance has been made. We just split the ions. Think of it like Fruit Ninja. Okay. So, that's kind of your review and a little sneak peek into what the quiz is going to be like. Are there any questions? No? Okay. Does anyone need me to stay on this longer? Do you have a question or are you just flexing your hand? Okay, perfect. So it's a bit of a doozy of a quiz, as you guys are seeing. There's a lot to know, but it's also not impossible. If you really look at this, it is just a repeated process, right? Look at all the color coding. It's a repeat. Okay. We're now going to switch over and see some of these reactions in lab because it's kind of nice to be able to see what we're talking about. All right. And a lot of chemistry is hard to see always, especially when we talk at the particulate level. We're going to have some fun. So this is what today is going to look like. Everybody, if you're a physical paper person, you need to pick up types of reaction lab and maybe the quiz practice. If you're a digital person, there is a Canvas assignment known as types of reaction lab. Download the types of reaction lab handout. Okay. Today's lab is going to be all about phone away. Today's lab is going to be all about types of reactions. So we're going to do station rotations. We have 4 types of reactions that we're going to examine. Okay. The way that the stations are going to work is it's going to go, everybody follow my hand. A reaction, B reaction, C reaction, 1D reaction because I have to run it. I have to run it because it involves quite a bit of fire. Then it goes to A, B, and C. So what you guys will do is you're going to split into groups. A, B, C, D comes back to the middle. It's like a flower petal. You all meet at D. So there's going to be 2 groups that meet at D with me. And then otherwise, everybody has their own A, their own B, their own C. A, B, C, okay? But I'm lab station 4D in the middle for the 2 groups, okay? And what you have is you have a series of reactions you're going to test. You need to fill out this handout because you are going to submit this handout into Canvas for a grade. It's a mainly completion grade, but I really don't think you should get any of it wrong. That would be a real dumb butt move. You're literally looking at it. Okay, so don't be a dumb butt. Okay, write your observations. And I even give you the formula so you know what you're making. So, all of these require either some type of like chemical or flame. Unless you're completely spastic with your hands, you really shouldn't be worried about safety right now though, because you're going to be at max droplet dropping in. If you're a little nervous about it though, grab gloves if you're the one that's handling the chemicals. Otherwise, don't be a dummy. Don't throw the glassware around. Don't create an opportunity for spillage. If you're just literally pipetting up a couple drops and dropping it into certain things, okay? It's not too rough. So that's all I ask is that in order to save the environment a little bit, and you're welcome to grab glassware. In fact, TAs, could you please put a couple goggles at every station that has chemicals? Okay. That is all that you really need to need. The instructions are here for you. I'm going to trust that you can read instructions. Okay. And each station only takes about 5 to 6 minutes max. Okay. And your goal is by the end to have completed this handout. Remember, station D is with teacher at lab 4. Okay. The only thing that you then are doing creatively is answering these questions. Okay. And then you submit it to Canvas. Are there any questions about my expectations about how to cycle through this? I'll kind of shout, okay, switch. Please don't switch prematurely because then we get buildups. Okay. So just stay at your station until I say everybody switches. But are there any questions? Okay, before you get up and go to a station, we're going to spend 3 minutes reading through the instructions. 3 minutes before you get up, and then I'll split you up into your teams. Just spend 3 minutes reading through the instructions of each lab. And those of you at home, if you are not here today, you need to schedule a time with me during seminar or lunch or something when you come back to do this.